Good morning, everyone. Welcome back for another exciting day in mathematics. Whoop, whoop. Warm up 44 for right now over there. I'll think about it. 44 is on your screen. Let's get started, please. Focus, people. Focus, people. Warm up 44 shouldn't take you long. Let's see how you do with that. Let's wait to make sure that they're not here. All right. All right, y'all ready? Yes, Mr. Q. All right, here we go. For the sake of time, it says graph f of x equals 1 over x. For that one, we needed a table x, f of x. And we use -2, -1, 0, 1, and 2. So if we substitute -2 here, it's -1/2. If we substitute -1 here, -1 divided by 1 is -1. If we substitute a 0 there, we can't have 0 in the denominator, so that's undefined. If we substitute 1 is 1. Substitute 2 is 1/2. So to graph that, all we needed to plot the points, 2 and 1/2. And -1, -1, and then 1, 1, 2, 1/2. And of course, by now we know about the asymptotes. We'll get more into that in a little bit. Number 2, we need to rewrite this. So we got g of x equals, who remembers how to rewrite these? Yeah, you put a 1 in the front, so that becomes a fraction. So it's a fraction of 1/4. F of x plus 4 minus 3, and it's a square because it's a quadratic. So, to graph that, we start off with our 5 points, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. All right. However, we know that we're going to move it in which direction, people, according to this? 4 steps to the left and what? 3 steps down. But before we do that, we need to do this part. 1/4. What does that mean, Mr. Q? That means that it's going to cut the values into fourths. So if this value right here is 4 times 1/4, what is 4 times 1/4? That's 1. So that means instead of -2, 4, it's going to be -2, 1. So this one comes down here, and this one comes down here. This one goes to 1/4, 1/4, and 0. So now I have these 5 points right here. I'm going to move them 4 to the left and 3 down, 4 to the left, 3 down. And your function's going to compress like that. Number 3, let's rewrite these. A to the -2, if we put that over 1, we do the reciprocal, so it's 1 over a, but the negative turns into a positive. So once again, we cannot have negative exponents. B, any number to the 0 exponent is always 1. Next, distribute, we end up with 1 to the -3, x to the -3. Once again, we have negative exponents. We do the reciprocal, so that means it's x to the +3 over 1 to the +3, which is x to the 3rd over 1, which is x to the 3rd. Next, look up. If x to the 3 plus 5 was x to the 3 times x to the 5. So what does this become? Well, that becomes 5 to the x times 5 to the -2. Yes? So far so good? But can we have a negative exponent, Mr. Q? No. So I write 5 to the x, and the 5 to the -2, I send it to the denominator, change that to a positive. So 5 to the x over 25. Last but not least, divide. Is it in standard form? Let's see, 2, 1, 0, 1, 0, yes. So 9x to the 2nd plus 6x plus 1 divided by x minus 1. 9x times x is 9x squared. 9x times negative 1 is negative 9x. Subtract. Distribute that here and here. This cancels. We're left with 15x. Bring down the plus 1. So, positive 15 times x is positive 15x. Positive 15 times negative, that's negative 15. Subtract, distribute here and here. This cancels. That leaves us with 16 as a remainder. Answer, 9x plus 15 plus 16 over x minus 1. Oh, x minus 1. Okay, we good? Yeah? All right. Send me your warm-up, please. Let me send you the code. Okay, we good? All right. Copy the agenda, please. Warm-up 44 done. We're still in the middle of rational functions, doing a quick intro for graphing and getting used to the asymptotes and all that. Okay. Tonight's hopefully 8 rational functions graphs. Last night I left you 6 of them. Hold on to those for the sake of time. I'll open up an assignment later on. Some of you are like, yes. Some of you are funny. Funny. Bah. Once again, warm-up 44 done. Rational functions. Tonight's home play what? 8 rational functions graphs only. All right. So, copy the code to access the home plate, please. UDAKL. 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 All right. So, with that said, those were the 6 from last night. Turn to your neighbor, let them know which one gave you more problems. See what I did there? Problems. Some of you are like, Mr. Q, this was squeezy. Squeezy, that's my word. Squeezy. All right. We good? All right, so tonight looks like this. Bam. Bam. Let's go. Yeah, we're going to go over a couple things today with a lesson that's going to cover from the home plate. Yeah? All right, here we go. Get a Cornell note ready, please. Also, I had a sign up on the screen to get at least 3 graph papers. If you haven't gotten those, get those, please. You're going to need them for the sesh. 3 graph papers. Bah. It says, I can solve and graph rational functions. I can solve and graph rational functions. And I have some of you coming in and grabbing graphs and taking them. Please don't sell them. Bah. I want to see eBay Q graph paper on eBay. All right, so we're in the middle of rational functions, yes? Yes, Mr. Q. All right. Question. What are 2 critical attributes that rational functions have? Don't look at your notes. Think about it. What are 2 things that are a must for rational functions to have? Tell your neighbor, and then type them up on the screen, please. Tell your neighbor 2 things that are critical of rational functions. Type them in on the screen. No notes. Go. You can either write it or there's a text box that you can open. far, I see some of you writing fractions. Very good. That's one thing. What's another thing? Rational functions should have 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. They should have an equal sign or have to be an equation and one fraction. Yes, some of y'all? Pretty good, yeah? All right, so we got that. So yesterday I talked about steps. The first step that we took was identifying the vertical and horizontal asymptotes. You guys remember those? From there we did an input-output table, and then we graphed. So I gave you guys a general rule, then applied it to the rational functions. There it is. Then I said within that rational function there are asymptotes, and I said we're going to focus on vertical and horizontal for right now. And we said the horizontal one is K, is that correct? And horizontal meaning it's a dotted line going sideways like that, is that correct? Yes, Mr. Q. And then H represents the vertical asymptote, which is a line going which direction? Up and down, dotted line like that, to indicate it's invisible. So far so good, yes? So then from there we went and identified the asymptotes for those, then these. From there we got to the graphing portion, there and there. However, today I want to practice and I want to introduce a couple of things that I left you guys for home play on 2 things, but we're going to add some more. So on your graph paper, get that in front of you. Copy this one, example 2 mega cube on the top left. Get the graph paper, put your notes on the side. We're probably not going to visit the notes anymore. We're going to focus on graph paper right now. So write that down at the top left. It says graph the function g of x equals 1 over 2x minus 4 minus 3. Let me send that to your screen. Give me a second. All right, some of you already started graphing ahead of me. That's fine. That's okay. If you haven't, here we go. Here goes the process one more time. First things first, we need to identify our horizontal asymptote, or our g of x. Turn to your neighbor, let them know what our horizontal asymptote is, or our g of x. Tell your neighbor. What's our g of x? Let me go with, after all that talk with your neighbors, let me go with German. German, what's our g of x? -3. Box it. There it is. -3. We go to -3 of y, plot your point, and then a dotted line going through that. There it is. Let me make that a little bit thicker. Let's see. A little bit better, yeah? Okay. Next, we need our vertical asymptote, or our VA. X equals. Tell your neighbor what to do in order to find that, please. What do we do to find our VA? All right, pass someone. German. Carlos, what do we do? 2x minus 4 equals to 0, and then solve. Plus 4. We end up with 2x equals 4 divided by 2. X equals 2. That's our VA. So at +2, straight line down, dotted line, up and down. There it is. All right. So now that we got our VA and our HA, what do we do next, Mr. Q? Think about it, guys. You guys did that last night. Tell you what is the next step to graph that function. All right, good conversation. Carlos, pass someone. Scarlett. Yeah, you get a table going. All right, so now we need x values. So for those of you that forgot, what x values do we use? Well, we first focus on our VA. Look up. Here it goes. I'm going to highlight it. What's our VA? Positive 2 of x. Is that correct? So I need how many values from the left, how many values from the right? 2 and 2. So 2 from the left is 0 and 1. So I'm going to write 0 and 1. How about from the right? 3 and 4. All right, so let's write our fraction over here. We got 1 over 2 parentheses minus 4 minus 3. I'm going to zoom in for that work. There it goes. My first value is 0. So we got 1 over 2 times 0 is 0, and that leaves us with what? Negative 4 minus 3. So what is negative 3 minus 1/4? That's negative 3 and 1/4, and negative 3.25. Negative 3.25. Here it goes again in case you didn't see it. Negative 3 and negative 1/4. What is 1/4 in decimal? 0.25. Is that correct? So negative 3 and negative 0.25 is negative 3.25. All right, let's do that again now for the number 1. 1 over 2 parentheses minus 4 plus, oh no, it's minus 3, my bad, minus 3. So we substitute the value of 3. So that gives me 1 over 2 times 3 is 6. What is 6 minus 4? 6 minus 4 is 2, Mr. Q. All right. Minus 3. So we got negative 3 and positive 1/2, so that's negative 2.5. Negative 2.5. Did I skip the 3? What is it? Oh, my bad, I skipped 1. I did that on purpose to see if you guys were paying attention. So now that we did the work for 3, let me put it down here. Good eye, Gloria. And who else? Carlos? Let's go. All right, so let's do that for number 1. My bad. My brain's going faster than me today. 2 parentheses minus 4 minus 3. We substitute the value of 1. Here it goes. What is 2 times 1? 2 minus 4. Negative 2, is that correct? So it's negative 1 over 2 minus 3. So what is negative 3 and negative 1/2? That's negative 3.5. Negative 3.5. Yeah, we good? Yes, Mr. Q. All right, good. Miguel, you good? All right. So we got 1 over 2 parentheses minus 4 minus 3. And then we got the 4. So 1 over 2 times 4 is 8 minus 4. That's 4 minus 3. So we got negative 3 and positive 0.25. So that is negative 2.75. Negative 2.75. All right, let me zoom out. Let's graph. I'm going to switch to green. So I'm going to start with this coordinate. 0, negative 3.25. 0, negative 3.25 is right there. Next one. 1, negative 3.5. 1, negative 3.5. We just need those 2 points, and then we connect them with a little curve. And look up. As soon as you start getting closer to the vertical asymptote, curve it like this, going that direction. Because remember, it cannot touch the asymptotes. go with this one. 3, negative 2.5. 3, negative 2.5. And 4, negative 2.75. 4, negative 2.75. And again, curve it. And notice it gets close to, but it doesn't touch the asymptote. All right, send that to me on the screen, please. I want to see what you did. All right, from 1 to 5, how comfortable are you with this so far? Where are we at? Yeah, 5 4s, couple 2s, 3s, 4s, okay. 3s, okay. So we're going to continue, but I'm going to add a couple more things. So here we go. Go to the next coordinate plane, write this down. Number 3. Look at the instructions. They changed a little bit. It says, graph the function and identify the domain and range. G of x equals 1 over x plus 1 minus 2. All right, so graph the function and then identify domain and range. So in other words, we're doing the same thing that we just did, but now we're just adding domain and range. So I'm going to give you a head start so you can graph that by yourself. I'll give you time, very similar to the one we just did, and see how you do with that. Go. All right. Let's see. Horizontal asymptote, or our G of x. What'd you get for that, Miguel? Negative 2. Hands, have you got that? That is correct. So negative 2 is down here. There it is. Next, we need a VA, vertical asymptote, x equals, pass on one, Miguel. Julian? Negative 1. Hands have got negative 1. That is correct. Negative 1 of x is right here. There it is. Now we need to graph it. To graph it, we need a table. X, G of x. So, printer and everyone know what x values did they use for the table. Then Julian's going to pass someone. What x values did you use for the table? All right, Julian, pass someone. Leo. So I'm going to start from left to right. Negative 3, negative 2. Was it? Wow. 0 and 1. Leo said same thing, and like he gave like a 0, 1, 2, negative 2, and negative 3, and it's not the same thing. I'm writing it in ascending order. So, with that said, I'm going to use this, but I'm going to go pretty fast to make sure we got the values. Here we go. If I substitute negative 3 here, what is negative 3 plus 1? Negative 2, so that's negative 1/2 minus 2, that's negative 2.5. Next one, negative 2 there. Negative 2 plus 1 is negative 1. 1 divided by negative 1 is negative 1 plus negative 2. That's negative 3. Next, if I substitute 0 in here, 0 plus 1 is still 1. 1 divided by 1 is 1. Minus 2, that's negative 1. Substitute the 1 in here. 1 plus 2 is 2. That's a 1/2 minus 2. That's negative 1.5. And if you got that by yourself. All right, so let's plot those. Negative 3, negative 2.5, negative 3, negative 2.5 is right there. Negative 2, negative 3. curve it. 0, -1, 0, -1, and 1, -1.5. Hands if you got that. All right. From 1 to 5, I'll come to right there. All right, 4, 5, 4, 5, okay. However, now we need a domain and a range. Domain, look up please. Bracket x such that, so look up. If I was to graph this part of the graph, the arrow indicates that it keeps going to what? To infinity, is that correct? However, where does it stop? Can it cross -1 of x? No, because there's the asymptote, is that correct? We cannot touch it. However, it continues over here. Arrows indicate it goes to positive and infinity, except for which value, everyone? -1, is that correct? So we're going to write that x equals all real numbers. Except what? Except which x value? So x cannot equal -1. Write that in there, please. Good morning, Mr. Q. And close the bracket. Yes. No, she's asking. Alrighty. Bye. All right, let's go to the range. Range. We write g of x such that. So now the range, starting from the bottom. So look up. So this arrow down here keeps going to what x values down here? To -infinity. Is that correct? And this one keeps going upward to positive infinity. So which values can I use for y? All values except which one? All values except which y value, everyone? -2. So that means we're going to write that our range, g of x, is equal to all real numbers, comma, except g of x cannot equal -2. Send that in on the screen, please. Go to the back of the graph and let's do another one. Here it is, example 3Q. See if you can do this one completely by yourself. Asymptotes, graph, and domain and range, please. We got g of x equals 1 over x plus 2 minus 3. I'll give you guys a head start. Copy and go. What'd you get for our HA? -3 of g of x. Hands, have you got that? All right, so we go to -3, which is down here. Let's get our HA sketched. There it is. And what is our VA, Eileen? -2. Hands, have you got -2? That is correct, -2. And once again, in case you forgot, K, or the constant, is our HA. To find our VA, we set the denominator equal to 0 and you solve, and that's how you get our VA. All right, now we need 4 numbers for our table. So you neighbor, what 4 numbers you wrote down? Then we're going to pass it to someone, or Eileen's going to pass someone. All right, Eileen. Carlos, what 4 numbers? -4, -3, -1, and 0. Hands if you got those 4. That is correct. Now, before I move on, turn to your neighbor, let them know, how did we get those numbers? Turn to your neighbor, because some people are still kind of like a little bit iffy on that. Where did we get those numbers from? How do we get those numbers? Let's go with, who haven't we called on? Call on Leo. Leo, how do we get those numbers, Leo? 2 on each side of the vertical thingy, he said, of the vertical asymptote. So here's the vertical asymptote at -2. We need 2 values from the left, -4, -3, 2 values from the right, -1 and 0. Okay? So from there we take our equation, 1 over parentheses plus 2 minus 3. It's going to go fast, so keep up. We got -4 in here. -4 plus 2 is -2, so that's -1/2. Minus 3, that's -3.5. Next value, -3. -3 plus 2 is -1 divided by 1. That's -1 minus 3, that's -4. -1, bless you. -1 plus 2 is +1 divided by 1 is 1 minus 3, that's -2. And 0 in here leaves it with 1/2 minus 3, that's -2.5. So we got -4, -3.5, -4, -3.5 right here. -3, -4, -3, -4. Connect them, curve them. There it is, -1, -2. And 0, -2.5. Connect them, curve them. There it is. Hands if you got that by yourself. All right, next, domain. X such that X is equal to, let's see, arrows going to the left, infinity, arrows going to the right, infinity. Which is the only value we don't use for X, everyone? -2. So X is all real numbers, comma, except for it cannot equal to -2. Range. G of X such that G of X is equal to all real numbers. Look at it, going from the bottom to the top, except for which value, everyone? -3. So G of X cannot equal -3. Send that in, please. From 1 to 5, I'll come to party with this so far. 5 4s, 5 4s, 2 3. All right. Once again, reminder, some of you that are struggling with this, you need to come see me in the morning. I get here at 7 in the morning, people. All right, next. Turn the paper over. Copy this one, example 3 mega Q. 3 mega Q. G of X equals -1 over X minus 3 minus 5. G of X equals -1 over X plus 3 minus 5. Once again, I'll give you a head start. Then we'll go over this together. Hurry up, please. 1 minute. Go. To someone. Or who went last? Was it Leo? I'm saying he was last. All right, let's pass it to Eileen. Eileen, pass someone. Geo, what's our HA? -5. Hands if you got -5. That is correct. So you plot your point at that is X. At G of X, -5, which is down here. I did that to see if you guys were paying attention. And what is our VA, Geo? -3. Hands if you got -3. That is correct. So we plot our VA. There it is. Let me stretch this a little bit. There it is. Next, we need to graph that. So I need a table, G of X, and then we have X on the left. Tell your neighbor the 4 values that you used for our table, and then Gio is going to pass someone. What 4 values did you use for that? What 4 values? All right, Gio, pass someone. Autumn. -5, -4, -2, and -1. All right? So let me zoom in to do the work, this. Now, notice it has a negative in the front now, yes? Negative, and then we got 1 over parentheses plus 3 minus 5. Let me zoom in. Here it goes. So, if I substitute negative 5 in here, so that leaves us with negative 5 plus 3, that's negative 2, is that correct? Times the negative, it becomes a what? Positive 1/2. So negative 5, positive 1/2, that's negative 4.5. Do that again. Next value, negative 4. Negative 4 plus 3 is negative 1, is that correct? Times the negative becomes a what? Positive. So 1 over 1 is 1 minus 5, that is positive 4. Next one. We got negative 2. Negative 2 plus 3, that's positive 1 times the negative is negative 1 over 1. That's negative 1. That's negative 6. And last but not least, negative 1 over parentheses plus 3 minus 5. And now we substitute negative 1. Negative 1 plus 3 is positive 2 times the negative is negative 2. So negative 1/2 and negative 5, that's negative 5.5. Let me zoom out. Start with the left side. Left side. I got negative 5, negative 4.5. Negative 5, negative 4.5 is right here. And negative 4, positive 4. Oh no, negative 4, negative 4, sorry. Negative 4, negative 4. Negative 4, negative 4. Look up. There it is. The other side, negative 2, negative 6. Negative 1, negative 5.5. And that's how you graph those. We just need the domain and range. So, put into practice, guys. Do that home plate for tonight. See you guys tomorrow. Bye.